Hello everyone, my name is Nikita Sawant and I am a third year information technology student at Dr. D.Y. Patil Institute of Technology, Pimpri, Pune. In this video, we are going to dive into HBase, a highly scalable and distributed NoSQL database. Have you ever thought about how companies like Google and Facebook manage massive amounts of real-time data? HBase is one of the key technologies behind it. In this video, we will break down what HBase is, how it works, its architecture, and why it is important in cloud computing. So let's get started. So what exactly is HBase? Simply put, HBase is a NoSQL distributed column-oriented database that runs on top of Hadoop. Unlike traditional relational database such as MySQL or PostgreSQL, HBase is designed to store and process huge amounts of unstructured or semi-structured data in real time. So it is a column-oriented database. HBase organizes data by columns, offering efficient storage and retrieval. Next is real-time data access. We can access data in real time and optimize for instant read and write operations. It also handles unstructured data and semi-structured data. Imagine you have a database that stores billions of rows of customer information for an e-commerce platform. A traditional relational database would struggle with such large-scale data, but HBase can handle it easily. That's why companies like Facebook, Twitter, and LinkedIn use HBase to store and manage vast amount of data efficiently. Now, why do we need HBase? Imagine you are running a social media platform where millions of users are constantly liking, commenting, and posting updates. If you store this data in a traditional relational database, it would slow down as the number of users grows. But what if you had a system that could store and retrieve massive amount of real-time data quickly, even as it scales? That's exactly what HBase does. It distributes data across multiple servers, ensuring fast and efficient access to large datasets, making it perfect for handling real-time applications like social media, IoT, and big data analytics. Features of HBase. Now let's take a look at some key features of HBase that make it unique. First one is scalability. HBase is highly scalable, meaning it can handle massive amount of data by distributing it across multiple servers. As your data grows, HBase can expand by adding more machines. Next is high availability. HBase is built on Hadoop's HDFS, that is Hadoop Distributed File System, which ensures that data is always available even if some servers fail. Next is column-oriented storage. Unlike traditional databases that stores data in rows, HBase stores data in columns. This makes it super fast for searching and retrieving specific species of information. Next is automatic sharding. HBase automatically breaks down large tables into smaller chunks called regions and distributes them across multiple servers. This ensures better performance. Now, to truly understand HBase, we need to break it down into five key components. Let's go one by one. HBase tables, the building blocks. HBase stores data in tables just like a traditional database. Each table is made up of rows and each row has a unique row key. Within a row, data is stored in columns which belong to column families. These tables are split into smaller parts called regions and stored across multiple servers. This is what makes HBase scalable. Next is regions and servers, which are responsible for managing the data. So think of a region as a chunk of data from an HBase table. Each region contains a range of rows. When a table is small, it starts with one region, but as data grows, the region splits into two and is distributed across different servers. Region servers. These are the workers that manage multiple regions. They handle read and write operation and keep everything running smoothly. Data is first stored in memory storage before being flushed to disk as H files. third one is H master, the brain of the HBase. The master is the brain of the HBase. It manages region servers and makes sure everything is running properly. So the responsibilities of the H master is assigning regions to region servers, balancing the load to prevent any one server from being overloaded, handling schema changes like adding new columns to a table. Without H master, HBase would not function efficiently. Next is Zookeeper, which is the coordinator. Zookeeper is like a traffic controller for HBase. It ensures that only one HBase is active at a time. It helps in region server failover, meaning if a server goes down, another one can take over without data loss. It also keeps track of metadata and helps coordinate operations. Next is HDFS, the storage backbone. HBase is built on top of HDFS, which provides a reliable, scalable storage system. Data in HBase is stored as H files inside HDFS. It also uses a write head log WAL to ensure durability, meaning even if a failure occurs, the data is safe. Next is how does HBase work? The first step is data work writing data into HBase. When a client writes data to HBase, it follows the steps. First, data is written to the write ahead log. This ensures that data can be recovered if there is a crash. Then it's stored in memory storage for quick access. Once memory storage gets full, the data is flushed to disk as an H file inside HDFS. Next is reading data from HBase. When a client reads data from HBase, first it checks memory storage for most recent updates. If data isn't in memory storage, it looks for H files in HDFS. Then the result is then returned to the client. Next is region splitting. As a region grows due to more data being added, it splits into smaller regions. These new regions are assigned to different region servers to distribute the load. This ensures scalability and prevents a single server from becoming overwhelmed. Next is com- compaction, keeping data efficient. Over time, multiple H files are created as data is written. HBase performs compaction, which means merging small files into larger ones. This reduces the number of files that needed to be read during a query, making it faster and more efficient. Now we will see the difference between HBase and the RDBMS. Now you might be wondering, how is HBase different from a normal database like MySQL? So here is a quick comparison. Uh, Features: data model in HBase, column oriented; in a MySQL, row oriented. Scalability: HBase is highly scalable. MySQL has limited scalability. Query language: it uses HBase API while MySQL uses SQL. Schema flexibility: HBase is schemaless while MySQL has fixed schema. Real time processing: in HBase it is possible. In MySQL there is no real time processing. So if you are working with structured data and need transactions like bank records, MySQL is a good choice. But if you need to store huge volumes of data and perform real time analysis, HBase is the way to go. Next is use cases of HBase. HBase is used in various industries where handling large data set in real time is crucial. Here are some real world application. The first one is real-time analysis. So it analyzes the data as it arrives. HBase provides low latency access for immediate insight. Next is IoT data storage. So HBase is perfect for storing real-time data from IoT sensors such as smart meters, traffic monitoring, and healthcare devices. Next is social media analytics. Facebook uses HBase to store and analyze billions of messages and posts from users worldwide. Now these are some basic steps to install the HBase. So first one is install Java and Hadoop. Since HBase runs on Hadoop, make sure Java and Hadoop are installed on your system. Step 2 is download the HBase. Go to the official Apache HBase website, download the latest version, and extract the files. Next is start the HBase. Run the following commands in your terminal to start the HBase. Next is access HBase shell. To interact with HBase, open the shell with following command. Step 5 is create a table and insert data. Run this command to insert the data. Now conclusion. So to summarize, HBase is a powerful NoSQL database designed for handling huge amount of data in real time. Its scalability, fault tolerance, and fast read-write capabilities make it as a great choice for big data application. Whether it's social media analytics, fraud detection, or IoT storage, HBase is widely used in the industry. Thank you.